Okay. Can we start now?
Yes, sir.
Okay, okay. We'll go through a few more examples. Page number 58, 59. Yes, right. Next example. Right. A moving body. A moving body is opposed by a force per unit mass. Per unit mass of value Cx and a resistance per unit mass. So both of them, you might have understood, both of them are opposing force, resistance per unit mass of value bv square. Okay. Find velocity of the particle in terms of x if it starts from rest. If it starts from rest. Okay. So this is a moving body. Okay. Two forces are there. Say moving in this direction. Say this is position of the body at any instant t. Moving in this direction. Say moving along the x-axis. So it is opposed by force per unit mass of bv square. Both of them are opposing forces. Okay. Start. Forces acting on the body are horizontal motion. Forces acting on the body are at one opposing force per unit mass of value Cx. Resistance per unit mass of value bv square. And therefore net forces F equal to Cx minus bv square. Right? Both of them are negative. Both of them are opposing force. Resistance is always opposing. Okay. Then down mass into acceleration equal to minus Cx minus bv square. Let acceleration equal to, how to consider acceleration? We have three options. One is d square x divided by dt square. Other is dv by dt, and one more is v dv by dx. Acceleration. These are the three options. Which one we have to consider? See, See the right side. Right side of the equation contain x and v. So if you consider dv by dt, then there will be three variables, v, x and t. And differential equation in three variables cannot be solved. Right now? So we should consider it as v dv by dx. There is no any alternative for us. Okay, no any choice. We don't have a choice here. We have to consider it as v dv by dx minus cx minus bv square. Okay, no problem. Divided by m. Acha, sorry. What about the m? Here m equal to unit mass, na? Unit mass. We have to write the equation for unit mass. One minute. Just 1 minute. You try to solve the example. See how we can solve the example. Okay. Hope you might have solved the example. Can anyone tell me how we can solve the differential equation? How we can solve the differential equation? Anyone? Is it in a variable separable form? Is it in a variable separable form? Can we separate v and x? Anyone? Tejas, can you separate the variables? No. Can we use any substitution? No. Is it homogeneous differential equation? No. Is it exact differential equation? No. You check it. Okay. Can you find the integrating factor for the non-exact differential equation? Absolutely not possible. Is it linear differential equation? Saras, is it linear differential equation? Om. Mahika. Maitri. आणि कोणाचं नाव लक्षात आहे? जयश्री. आणि कोण आहे?
येस सर मी आहे.
हा सांगा. Okay, is it linear differential equation?
No.
Good. Kaustubh, is it linear differential equation?
Don't know, sir.
Hey, don't know कशाच काय? What is degree of v? Now whose degree we have to consider? Degree of v, na? Why v? V is in numerator, so degree of v is 1. Degree of dv by dx is 1. 1 plus 1 is 2. Degree of cx is 0. Degree of v square is 2. So degrees are more than 1. So is it linear differential equation? No, it is not linear differential equation. Hope everyone is getting this.
Yes sir.
Right.
Yes,
So how to solve this? Yes, anyone? Now this is non-linear differential equation. Of which type? Type number?
Bernoulli's linear differential equation.
No Bernoulli's. For Bernoulli's, what is required? For Bernoulli's, what is required? Bernoulli's is like this, na? Let me change the page, and I'll write it over there. For Bernoulli's, it is like this. See, I'll write Bernoulli's in y. Okay, dy by dx plus py. This py required here. Why not here? Why is not here? y is not with the derivative, equal to q into I raised to n. This is required. No, it is not in this form. This is Bernoulli's. So it is not Bernoulli's also. Is it of this type? F dash of y dy by dx. का Bernoulli's आहे. बघू आपण check करू. I am also at this moment not much confident. Okay. Is it of this type? I think it is of this type. Right now? If I make the rearrangement, it is like this: v dv by dx plus bv square equal to minus cx. Right now, it is
Yes,
of
sir.
this type.
Yes,
Right?
sir.
Right. It is of the form. I'll write like this: of the form f dash of v dv by dx plus f of vp equal to q. Okay, so substitution is u equal to v square. So du by dx equal to, what is du by dx? 2v dv by dx. Okay, so 1 upon 2 du by dx equal to v dv by dx using substitutions in 1. Okay, so it is half du by dx plus bu equal to minus cx multiplied by 2. Now this is linear in u. 2 is linear differential equation in u. Comparing with p and q should be constants or functions of x. Integrating factor. Hope you might have understood it. Let me change the page. Let me go to the next page. Chain rule of integration by parts that I am using. Alpha as it is, integration, derivative of x 1, okay. Now we have to substitute u, then cancel the 2. Do all these things together. U, what was the U?
तर बाय पार्ट्स यूज करायचं आहे का चेन रूल?
Chain rule, na? Chain rule of biparts. Biparts ने केलं तरी चालू शकते, but it will take one more step. What is U? I forget the U.
dv by dx.
नाही U V च्या
v
फॉर्म मध्ये होतो.
square
1/v square or v square?
v square
v square e raised to 2bx equal to, we can cancel 2, let me consider minus sign inside. Okay, c minus sign I'm taking inside, so e raised to 2bx divided by 2 cancel, so 2b square minus of x e raised to 2bx divided by b only, no? 2 is cancelled. Now we want to consider initial condition. At time t equal to 0, x equal to 0, v equal to 0. Starts from rest, na? So 0 equal to okay, c by 2b square minus 0 plus a. So v square e raised to 2bx, जरा simplify करून टाकते है ना? We'll simplify it. C e raised to 2bx divided by 2b square minus cx e raised to 2bx divided by b minus c divided by 2b square. Okay, cancel this exponential term, that's it. V square equal to c divided by 2b square
सर वो प्लस माइनस भी कैंसिल होगा ना?
प्लस माइनस क्या कैंसिल होगा? नहीं ना, कुछ नहीं कैंसिल होगा. सही है, which is correct. You cross check. Which is the answer? We'll go through the next example. Can I change the page now? चलो काफी एग्जाम्पल सॉल्व करने हैं हमें. Let me change the page. 62 now. A bullet is bullet Raja. Okay, so a bullet is fired into sand tank its retardation is proportional to of velocity. Square root of velocity. Show that in time 2 root v by k, the bullet will this is v naught, come to rest where v naught is initial velocity. So say this is the sand tank which is full of the sand. Okay, and then at a time t equal to 0, a bullet is fired here. Okay, fired means it the velocity will be not 0. Velocity is v naught. Velocity is 0. It will not enter the sand tank, right? So it is fired with the velocity v naught, and it will move for some distance, and then it will come to rest. So we want to find the time when it will come to the rest. Okay, so write down forces retardation. We'll write like this. Retardation of bullet is proportional to square root of velocity. Okay, retardation is acceleration only, proportional to square root of velocity. So acceleration equal to what should be written? Positive value of k or negative value of k? Yes, acceleration is increasing or decreasing. Retardation is there, na?
Decreasing.
Okay, so
Decreasing.
negative. Acceleration equal to minus k. Now, which form of acceleration is to be used? We can use it as dv by dt. अरे जरा शांत रहे क्यों? लेक्चर सुरू आहे, लेक्चर झाल्यानंतर बोलूया आपण. ठीक आहे. d square x divided by dt square, or we can consider as v dv by dx. Yes, which form of acceleration is to be considered? See, ultimately our aim is to find the time, na? So we have to consider acceleration as dv by dt.
dt.
So right, minus root kv. Separate the variable. Simple example, not too difficult. And integrate. What is initial velocity at time t equal to 0? V equal to v naught. Substitute. I am writing remaining part here. Our aim is to find when bullet come to rest. Yes, so it is v velocity will be 0. Rest means velocity 0. So t equal to 2 by k root v naught. That is what we want to prove. Hope you might have understood it. Next. Understood the problem? Let me go through the next page. Okay, 63 page number. Right. It is like this: a particle, right, is moving in a straight line with acceleration. So force is not given, acceleration is given. With acceleration k, x plus a raised to 4 divided by x cube. Directed towards origin. If it starts from rest at a distance a, small a is the distance from origin prove that it will arrive at origin at the end of time. So here also our aim is to find time. Yes, solution, better. Particle is having acceleration k a raised to 4 divided by x cube directed towards origin. Okay. Like the simple pendulum. Acceleration equal to minus k. Why minus sign? Directed towards origin, therefore. Right inside, negative sign. Acceleration directed towards origin. So, which form of acceleration should we consider? dv by dt or v dv by dx? If we consider dv by dt, what will happen? See, already x is there on the right side, and on left side we have v and t. So 3 variables will be there, and we cannot solve a differential equation with the 3 variables. Therefore, there is no alternative. We have to consider v dv by dx only. Hope everyone is getting this. समझते surround है. Right, now solve the integral. It is we can convert it into variable separable form. We can add a constant. Integration of 1 upon x cube minus of particle starts from rest at a distance e. Therefore, our aim is to remove the a, na? For that, we are considering this as the initial condition. Okay, x equal to k, so v equal to 0 minus k a square by 2 minus a raised to 4 divided by 2a square plus a. A equal to 0. Cross check it. Let me go through the next page. Have you written this?
Yes, sir.
Write it. So in fact, we are solving the differential equation twice. And actually, it is second order differential equation. If we substitute d square x divided by dt square. But
Sir, why A is 0?
why? The bracket will become 0, no? A square by 2, A square. After cancelling A square, you will get A square by 2, no?
Yes, sir.
Therefore, bracket is 0, therefore A equal to 0. Okay, let me continue. So, from equation number 2,
Age.
equation number 2 implies v square by 2 equal to minus k. I can take 2 outside. X square minus a raised to 4 divided by x square. Yes. So 2 will cancel. V square equal to, let me consider this minus sign inside, k, a raised to 4 minus x raised to 4 divided by x square. I have taken minus sign inside and let v from here. Taking root. Then around, since acceleration directed towards origin, considering negative root. But what is the v? Our aim is to find time, na? But what is the v dx by dt? Now we have to integrate this. And then we have to add a new constant. Yes, how we can integrate this? Let u equal to x square. Substitute all these values, and can I go to the next page fast? So put us faster. So let me go to the next page. So the difficult है x dx का है du divided by 2. Equal to, sorry, let's yeah, on the other side what is there? Minus root k by 2 है क्या?
Minus of integration root k dt.
Root k t, and then b is right. Okay, so I'll use this formula. Sine inverse of u divided by a square, huh? But u is, what is the u? X, I think. Now our aim is to find the b. Substitute. What is sine inverse of 1? 5 by 4. So this is the answer. Now we want to find time when particle reaches at origin. What is 0? X equal to 0. So half.
तर ते बघता का?
Huh?
ते बघा ना.
Okay. Half sine inverse 0 minus root kt plus pi by 4. So this is equal to 0 only. Minus root kt equal to minus pi by 4. Therefore t equal to pi divided by 2 root. Hope this is the expected answer. Yes. Next page, last page. चला एकच छोटासा पार्ट लिहायचा आहे, then we'll stop. Can I change the page?
Yes.
A motion in which acceleration is directed towards origin. Right? In case of pendulum, right, it tried to move to the midpoint, right? Na? So directed towards origin. Right? Pendulum we know very well. Every time the bob of pendulum try to move to the origin, this is the origin, this is mid path. Okay, so acceleration is directed towards origin and proportional to what? Acceleration is proportional to what? कशाला proportional असते? किसको proportional रहता है SHM में?
Displacement.
सिर्फ displacement?
Square.
Square of displacement. Okay, so like this. Square of or just displacement? I also forget it. It's not square, na? Proportional to, sorry, displacement. d square x divided by dt square equal to minus omega square x. This is the differential equation of SHN. Just remember this statement only. That will be more than sufficient. Probably there will be no any example on SHN. That's all about this topic. No any problem we are going to solve on the mass spring system. It will be not there in the, it is not there in syllabus and it will be not there in exam also. Don't afraid about that. This is all about the unit number 2. Okay. Tomorrow we'll start with the unit number 3. 4 or 5 topics are around 5 topics are there in unit number 5. Subtopics are there in unit number 3. We'll start with the reduction formulas tomorrow. So more difficult to understand at the first moment. Huh? So don't miss tomorrow's lecture. We'll start with the reduction formulas, and then day after tomorrow, that is on Friday, we have 2 lectures. In one lecture, 2 or 3 lectures, I don't remember. Friday, how many lectures we have? 2 lectures we have. So during one lecture, we'll go through the unit number 3, remaining part, and during one lecture, remaining lecture, we'll go through the MCQs, and then on Monday we have a MCQ test. Unit test is there, right now. So let me take the attendance. We'll start with B division today. Roll number 1. Absent.